This is my talk on why learning a bit of cryptography is good for you. And not to foreshadow anything, but Coursera's Crypto 1 course is quite good. So first off, I'm Colin. I've been a software developer for quite a long time, I realise now. And I've learnt about cryptography recently, relatively speaking, because in truth, like a lot of developers, I was relatively ignorant until far too recently. As you can see, I also work for CV Library, who are kindly sponsoring us, along with all the other good people. And I've got all the sponsors at the end of the slide, so I won't give us too much undue influence, hopefully. So, as developers, I imagine that a lot of us have been told not to write our own crypto and are generally scared of it. Certainly I'm scared of making a cock-up because it will have quite negative consequences, but ultimately as developers it really is very hard to avoid. A lot of the time we're using it without even thinking about it. We're using SSL and things like that, that are ubiquitous, and from a development point of view, things like SSL, we don't really have to think about it at all. It's purely just a configuration thing at this point, and in fact it's more an operation issue rather than actually a development issue. But we still have to deal with things. I mean, again, things like password hashing and things like that, they're actually pretty standard, hopefully, so that you shouldn't have to think too hard about it, and it's purely a case of make use of the good libraries that already exist. So as long as you're not following the sort of tutorials from the web that suggest using MD5 and ancient techniques that have been thoroughly debunked by now, then you should be okay. But fundamentally, we've still got quite a few bits where we're actually touching cryptography. Those sort of things hopefully are well defined, but not everything is. So there's a lot of things where we're generating things like tokens or secrets or passwords where we actually need to care. And then there's actually things where it's obvious, where we're communicating and we need to use a secure channel and we can't just simply slap SSL on it. And there are cases where we might do it to actually scale things out. So one of the reasons to learn about cryptography is to, as you learn about it, you actually realise that randomness is a really big part of the cryptography puzzle, and so much of it is actually tied in with randomness, and what we care about is down to our definitions of random as well, because it's not simply that the random numbers look are dispersed evenly in a field or anything like that. It's also that you can't predict what the random will be, because that's one of the fundamental things, is that given a set of random numbers that you've seen from a random number generator, one of the things that they really care about is that you can't then predict the next numbers or predict the numbers that have come before. So that's one of the big things that we have to deal with, because when we've used rand, for example, a lot in code. That's just a typical mathematical type random, in that it gives you a nice even distribution relatively. It's a bit old and antiquated as an algorithm, but you know, it does a reasonable job for just doing a mini sort of random number and just being able to say, oh yes, I want to pluck out this many messages out of another to examine or something like that. If you just want a simple distribution of things, then it's all fine. But if you actually want to use it for security purposes, it's a really bad idea. Whereas you want to really use a cryptographically secure one. And if you've done a course on cryptography or learned about it, read a book, then it gives you a much better grounding on what you do, because all of these things are generally built on this concept of having a perfect random source, so that you can actually effectively encrypt stuff using a random number generator in theory. So let's have a look at what happens when you don't get it right. So if you've actually got a a regular rand number. So what I've done is I've built a website. It's a quality site because, yeah, it's one of those ones where it's rude to hack someone else's software, so I've just built something up because the other thing is and then you'd have to report the problems. Not that I'm sure anyone's got this vulnerability, but it's got a sign-up form, and it will email you if you email you a new password when you want it. So let's try that. Oh no, it's limited to only big corporate email addresses, and I don't have one, so that's not going to work. Now, I happen to know that this is built using this crypt generate passwords module, so that's good. It generates secure passwords, but somewhere down here it does say something about the random number generators. So let's just search random. Oops. It says down, shall I highlight it? And it might not be appropriate from some sites because it uses Perl's RAND, so that's just your regular sort of thing. So let's have a look. How wrong could this go? So let's run my little attack script. Now, when I'm doing this against the Python's, oops, okay, it went wrong. Oh joy. This is the joys of live demos. Let's just restart things and hope that that fixes it. Oh dear. Of course it all works every other time. Hey! Just keep hitting it often enough. So yeah. So this is signed up for an account with this email address. It just generates a new one each time. So all I need to do is go back and log in. Yeah, the Python mathematical random number generator has a much bigger sort of internal state. So I end up having to make a lot of web requests to get a sample of numbers to actually be able to crack it. I need to make sure I get all of the password. Whereas Perl, all I need is actually one number. I just get two in order to make sure that I can break it. And presto, I've managed to log in, and I can now go and post my feedback. So that just, yeah, I've logged in fine. Thanks to the random number generator being just rand, I was able to figure out what that would do. Now, one of the reasons I could do that is because on this, whoops, how many times can I mistype it? On this page is that there is actually a random number leak. So there's a split test thing going on that drops a cookie that allows me to test out an A/B tester feature with the sign-up form, whether or not I display a field, and on it, it's spat out the random number generator. Well, the number from a random number generator. Now, that's not like the ones, it's not a number that will be used to generate the password, it's just a number generated by RAND. But based on that, I was able to predict what the next numbers would be from RAND, and therefore predict what it would use when I asked it to sign up my form. So when it then, in theory, sent the email to the big corp user, although there probably isn't a hacker or whatever, it would generate that password. Presto, my attack program then signs in with said password, and without ever seeing the email, which is good because I never actually implemented the code to send the email, I was able to sign in. So there's the problem with regular random. It's a case of, yeah, using the right type of random really does make a difference in the security concept. And it's not necessarily just purely, say, generating passwords. It's things where you care about predictability. So if you're, say, playing a game, like, say, poker or whatever, where you're having a computer generate a card deck or whatever, those sorts of things, and say there's actual something real at stake with it, say money or whatever, gambling site or whatever, those sorts of things, you probably care that somebody can't predict what the hand's going to be and be able to play a perfect hand. So it may be more than simply just passwords and tokens and session IDs and things like that you care about random being right. And then there are other applications. So another common thing that people do is store session data in cookies. You know, it's got to be a relatively small amount of session data, but you can do that. And it allows you to scale your website quicker because you can spread the load of storing all that data out to the clients. But you don't want people to be able to modify that, and you don't want people to be able to see what that data is necessarily and meddle with it. So you encrypt it. And that's all well and good, and until it all goes a bit wrong. And ASPnet and amongst others managed to get that wrong. They weren't actually doing that with the cookies, they were actually doing it with their view state thing, which I'm sure all developers love if they've ever encountered it, where they store this great big lump of text in the middle of a page. So let's have a go at that. So in actual fact, that feedback thing that I just did, that was using that sort of cookie. So if I go back to that, you see there, that me echoing back the feedback, that's actually been stored in a cookie. So if we have a look here, here's the cookie value, and that's using military grade encryption. It's AES-256, and if I were to say encrypt that exact same bit of text again, it would come out completely different. You know, it's really good. You know, it should be pretty resistant to cryptanalysis, all that sort of stuff. But I'm just going to use the server against itself to actually break that, because in this case there's a padding oracle. So if I just, let's hope the live demo gods are going to play ball. Now this one does require a progress indicator. As you can see, it's absolutely hammering the server with requests, and it's literally guessing each character. But that's really, you know, that seems like in some ways that it's taken a long time, but in terms of breaking cryptography, we're supposed to be talking at least decades, if not hundreds of years, to break encryption, especially something like AES-256. And this is because of it returning an error. Now, I had to artificially add in said error because the library on CPAN luckily doesn't expose this error normally, but it's quite a common mistake, or has been a historically common mistake to make. And you can see here that in actual fact there was more than just that bit of text encoded in the in that blob. There was also the username that was there, and it was it sort of helped prevent other users seeing that feedback and stuff if they weren't that logged in user and things. So if you just literally pop that into your own cookie and you weren't that user, then you wouldn't be able to see the thing echoed back. Not that that's all that relevant. So, as I say, yeah, this has, you know, all of these things have gone wrong in the past and are probably going wrong at the moment to some degree. The other thing about that is that that's actually quite malleable, what I've done there. So while if you were to modify it in certain places, it would throw an error and throw a wobbly, I could actually tweak the cookie a tiny bit, and I could actually change what's in there, because I haven't actually put any sort of authentication on the encryption. So if I were to actually put in a bit more effort, I could tweak the user or tweak whatever and actually do naughty things. Now, I'd have to probably come up with a better scenario than just providing feedback or something to actually make it worthwhile, but it's certainly very feasible given what I've done so far. And the important thing is I mean, hopefully, as part of this, I'm giving the idea that you should use the correct random, but one of the things is it's worth knowing about the vocabulary, because most of us have probably heard of things like AES and SHA-256 and all of these various things, and quite plausibly used them. But in truth, those aren't really the really interesting bits of the vocabulary. It's known that you want to use things like authenticated encryption, and that you want to use them in the right order, and the various ways that you put these things together, and that you want to use a CSPRNG, which is just the acronym for cryptographically secure pseudo-random number generator. Those are the things to look for. For example, with that password generator module, I knew I'd be able to use it in this talk from just having read the pod. I didn't need to look at the code to guess that I would be able to do what I did. I really didn't need to worry at all about that. I was, having learned the correct sort of things to look for, it's perfectly possible to have some idea of whether something is secure. There can still be other goofs in code, but you actually have a much better idea of what's going on. So here are some resources. As I mentioned before, the Coursera course taught the Crypto 1.1 is brilliant, and I'm sure Crypto 2 will be if it ever gets released. There's also some practical examples. The Coursera one, it's got lots and lots of practical examples with it. So, it's a proper university type course. So you've got actual programming labs, and you've got questions and things, and all of that helps reinforce the learning. And it's really good. So and you've got things like you have a look at a weblog and look at somebody actually attacking and breaking a padding oracle attack and things like that. And it's really cool. And then there's also forums so that you can all get together and figure out where you're going wrong and help each other. Crypto Pals, they go through a whole gamut of stuff and help you sort of basically code through figuring out crypto and things, which is really quite cool. And then there's a very new book called Serious Cryptography, which is really quite good from a programmer's point of view. The code for the website is Dancer2, and it's up on GitHub. The attack code is, because I just don't think that's a good idea to put up, because it's not that brilliant or advanced or anything. It's just, why give anyone a break? And thanks to all the speakers for helping provide this conference. So the next thing is, any questions? Okay.
How secure is it to use Perl random if you seed it from a properly random source?
So that was, how secure is it to use the normal Perl random if you've seeded it from a properly secure source? Is not. That's the fundamental thing, is that random numbers, there are basically, I think, three rough things that can go wrong. One is the seeding, two is the type of algorithm, and three is how wide your output is in effect. And fundamentally, if you're using the wrong type of algorithm in the first place, you may as well just give up. It doesn't matter where you're seeding it from, because ultimately, it just, you can look at a certain number of outputs and figure out the next outputs, which fundamentally breaks it. And the thing is that it may not be the actual output that you care about. Let's say it was a session ID. Let's say you've then SHA-256'd it afterwards, which is quite a common thing, which makes it look perfectly random. So you run it through an entropy checker and it goes, yes, your session IDs are perfectly good. But the thing is that that same rand call gets used in other places. And as you saw with my site, what I did was I was using random for the thing to check whether or not to actually do the toggle, to do the A/B test, and that leaked there. So I was able to see it from a different place, but it's fundamentally from the same random number generator in its state, and from that I was able to guess it. And in the case of the Perl one, it actually outputs the entire state if you've got the full random number. Now, a lot of the time we're truncating it, so it may be more challenging to get it and to figure out the state. But if you've got the pure thing, so in my case here, I made it really easy for myself because I'm lazy. But you see here, this is the full floating point number, and I can literally, it's just a case of put it back in and do a transform on it, and presto, I've got the exact random number state. It doesn't matter where you started from, it's completely irrelevant. Right. So, any more questions?
How do we can check back in
So essentially, yes. I mean, I basically just turned that back into the state, and then I just re-implemented random in code, because, I mean, the Perl random is actually a really ancient one, I believe, by Donald Knuth, a 48-bit transform, basically, and it's just like a couple of mathematical operations, and it's really trivial. So I just re-implemented it in Perl's code, because, you know, that was easier than trying to figure out how to reseed the internal one, because it's probably possible, but yeah, it was quicker to just re-implement it, and then just, you know, that password generator module, it allowed me to override the random function, so I just said, oh, here, use mine, that's got my nicely set up state, and presto, new password, which matched that one. Any more questions? Okay, thank you.